Hey everyone, and welcome back to another educational video of the Mile High Nomads. Today we're diving into a topic that confuses a lot of new pilots and even sometimes catches experienced ones off guard: the different types of altitudes in aviation. But first, I would like to bring up why you should subscribe to our channel. We are saving up to start a journey of a lifetime, buying our own plane to take it then for a spin to wherever the wind blows. Starting in Seattle, taking it through Europe, and with an unknown finish line, hopefully somewhere towards Asia. And we need all your guys' help. So before we start, hit that like and subscribe button to follow our journey. And now, let's get into it. When we say altitude, we don't always mean the same thing. In fact, depending on how you measure it, there are several different types of altitude. Not one, not two, but 5 different types of altitude: indicated, true, absolute, pressure, and density altitude. In this video, we'll break them all down and show you how they're used and explain why it's so important to understand the differences. Let's start with the simplest one: indicated altitude. This is simply what you see on your altimeter in the cockpit. In order to get an as accurate reading on your altimeter, we set the altimeter in the Colesman window using the local barometric pressure settings. And the instrument gives you your altitude above mean sea level, or MSL. Indicated altitude is what we use when we talk to ATC, when we're flying traffic patterns, and when we're reading sectional charts, because all those altitudes are based on mean sea level, MSL. For example, if the traffic pattern altitude is 1,000 feet above the field and the airport is at 500 feet MSL, you'd fly the pattern at 1,500 feet indicated on your altimeter, which is 1,000 feet AGL, which we will cover in a minute here. Next up, true altitude. This is your actual height above mean sea level. Most of the time, your indicated altitude and true altitude are very close, but they can drift apart depending on temperatures and pressures you fly through along the way. Charts, obstacles, and terrain are always shown in true altitude, measured from sea level. So when you're looking at a mountain that says 9,000 feet, that's 9,000 feet true altitude. You can think of true altitude as the real world altitude, whereas indicated is what your instrument thinks is happening, depending on the settings you put your altimeter on. True altitudes are particularly important for instrument flying, since all the altitudes on departure, arrival, and approach plates are measured in true altitude. What these plates actually are, I will break down in another video. Let's move to absolute altitude, which is the vertical distance to the ground directly beneath you in AGL, which stands for above ground level. For example, if you're flying over terrain at 5,000 feet MSL and your altimeter reads 7,000 feet, your absolute altitude is just 2,000 feet. And you are 2,000 feet above the ground. Considering the Earth, this altitude changes a lot during our flight, since we fly over hills, mountains, and canyons all the time. So it is especially important for terrain clearance, but also for maneuvers like steep turns or stalls, when you want to make sure you got enough air between you and the ground. Now, let's talk about pressure altitude. This is our altitude when we set our altimeter to 29.902. And will give us our altitude above standard datum plane. What does this mean? A long time ago, someone decided to measure the local air pressures at sea level in all different kinds of places and came to the conclusion that the average pressure is 29.902 inches of mercury, or for my fellow Europeans, 1,013 millibars. Because it's an average, it's rarely the case that we're actually dealing with this pressure. So why is this important? Because pressure altitude standardizes things. It allows us to compare aircraft performance regardless of local weather. For example, our takeoff and landing distances and climb performance. This is why we call 29.902 standard pressure. When you dial in 29.902 into your Coles window on your altimeter will actually show you your pressure altitude. A lot of people get confused here, because by doing this, you are basically telling your altimeter where sea level is at this moment. The altimeter settings we receive from weather systems like ATIS, AWOS or flight service actually tells you what the pressure would be at sea level based on the pressure at the airport you're at, which is pretty easy to calculate since for every 1,000 feet of elevation our pressure decreases with 1 inch of mercury, and people think they're dialing in the pressure at the field. If we did that, the altimeter would actually read 0 and not the field's elevation. If you've ever flown above 18,000 feet in the United States, you know you have to set 29.902 on your altimeter, so everyone's flying on the same reference. That's pressure altitude in action. We can also calculate our pressure altitude, which will be 29.902 minus the current altimeter settings times 1,000 plus your field elevation. So let's say the current altimeter setting is 29.45 and our field elevation is 1,500 feet. It'll be 29.902 minus 29.45 times 1,000 plus 1,500 is 1,970 feet. Finally, the one every student pilot remembers, density altitude. This isn't something you can directly read off an instrument, it's calculated. Density altitude is pressure altitude corrected for non-standard temperature. The same person that decided that the average pressure at sea level is about 29.902 also found out that the average temperature at sea level is about 15 degrees Celsius. This is important to know because that temperature will give us a starting point of how to know how the temperatures affect the thickness of the air. The higher the temperature, the more the air The higher the temperature, the more the air molecules are spread and the less dense the air is. And therefore, our density altitude will be higher than the pressure altitude. If the temperature is lower, causes the molecules to stick closer together, therefore making the air denser, and causes the density altitude to be lower than our pressure altitude. Because our wings, propeller and engine rely on air, they will react accordingly to this air density. Higher density, better performance, and the lower the density, less performance. So think of it like this. Density altitude tells you how your plane will perform. On a hot day at a high elevation airport, the air is less dense, so your wings and propeller produce less lift and thrust, and your engine produces less power. In our performance charts, we usually won't see our density altitude, but it will show pressure altitude with different temperatures. These refer to our density altitude. This is also the reason why some pilots call density altitude performance altitude. To calculate our density altitude, we have a simple formula to help us out, which is the outside air temperature minus the standard temperature at our altitude times 120 plus the pressure altitude. So let's take the pressure altitude calculated before, and let's assume it's a hot day, say 29 degrees Celsius at our 1,500 feet airport. Standard temperature at sea level is 15 degrees Celsius, but we are at 1,500 feet. Our standard lapse rate for temperature is 2 degrees Celsius for every 1,000 feet of elevation, which means with every 1,000 feet we climb, the temperature will decrease with 2 degrees Celsius. So the standard temperature at 1,500 feet will be 12 degrees. Now let's fill in the formula and see how the plane will perform. So 29 minus 12 times 120 plus our previous pressure altitude of 1970 equals 4,010 feet. So even though we're only at 1,500 feet, the plane will act as it would be at 4,010 feet, which will significantly impact our performance. That's why density altitude is so critical, because even though your indicated altitude might say 5,000 feet, your airplane might perform like it's at 8,000 feet. That means longer takeoff rolls, reduced climb performance, and sometimes dangerous situations if you're not paying attention. So let's recap. Indicated altitude is what your altimeter shows. True altitude is your actual height above mean sea level, MSL. Absolute altitude is your height above the ground, AGL. Pressure altitude is your altitude when the altimeter is set to 290.902, our standard pressure, used for performance and high altitude flight. And last but not least, density altitude tells you how the plane actually feels in the air. Understanding these different types of altitude is more than just a knowledge test question. It's what keeps you safe, efficient, and accurate as a pilot. If you found this helpful, hit that like button, subscribe for more flight training videos, and drop a comment down below about which type of altitude confused you the most when you first started flying. Thanks for watching, and I'll see you in the next video. Fly safe.